For blood test number 4 in 2025, when using Dr. Morgan Levine's biological age calculator, PhenoAge, we saw that my biological age was 35 years, which is 17 years younger than my chronological. Now, anybody can enter data and put it into a spreadsheet, but in today's video, we're going to take a look at the full lab test report, as I'm not just measuring 9 biomarkers, I'm measuring a whole bunch of other biomarkers, trying to cover any potential weak spots. So with that in mind, we'll take a deep dive into the lab test report and I'll provide subsequent analysis. Starting off with page 1. And note that for all of the data that I'm going to show, all of the test results that I'm going to show in today's video, I don't go to my doctor to ask to get those tests measured. I go to ultralabtest.com where I specifically pick the test that I want. I then bring that form to Quest Diagnostics or Quest Lab, which then gives me the results relatively quickly. So we can see that on May 27th, I tested around 7 in the morning, and then I had the majority of these results 2 days later. So if you're into blood testing like me and you'd like to help support the channel, you can do that by using the affiliate link in the video's description. All right, so let's start off at the top with the lipid panel, as death from cardiovascular disease is the top cause of death worldwide. And then let's take a look at HDL, or we'll start off with HDL, which I've coded as green, as that's movement that's data in the right direction. And that's good news for HDL because it's now 17 tests in a row where HDL is greater than or equal to 50 milligrams per deciliter. In contrast, for the previous 45 tests, so I've got 62 tests for HDL dating back to 2015. For the first 45 tests, HDL was lower at 45 milligrams per deciliter. So the relatively higher HDL, now greater than 50 for 17 tests in a row, is potentially important because what's optimal for HDL, at least for men, is in the 50 to 60 milligram per deciliter range. And that's based on a meta-analysis of 3.4 million people and an even larger study, a non-meta-analysis of 16 million people. Now, we may be able to add to this story as ApoA1 may be a better marker of heart disease mortality risk relative to HDL. And that's particularly important because HDL contains ApoA1 as shown there. Nonetheless, with that in mind, I measured ApoA1, so what's my ApoA1? And that's what we'll see on page 2. I'm going to have to jump around a bit. Unfortunately, Quest's lab test report doesn't put the apolipoproteins directly under the lipid panel, which would make the most sense. So I'm going to be doing a bit of jumping around in the video to try to be consistent with story. So for ApoA1, my data for this test was 137 milligrams per deciliter, which I've coded as red. Technically, I'd be orange. It's not totally red, as at first, it's better than the reference range at 115 milligrams per deciliter. But note the study that they're using for their determination of the reference range. It's from 2004. Interestingly, there's more recent data from this same study that they used to define their reference range from the Amoris study that was published in 2021. And there's also all-cause mortality data for ApoA1 that was published in 2024. So there's more recent data that suggests that the reference range is outdated. So with that in mind, my optimal range for ApoA1 is 150 to 180 milligrams per deciliter. And with that in mind, my 137 is just a bit below that, so I've coded it as red. And that's one that I'm going to try to consistently push higher than 150. And if you're wondering where I'm getting these data from, I have a new Patreon tier dedicated to specifically what's optimal for biomarkers. Now, if you just type in what's optimal for any of these biomarkers into your favorite LLM, it'll give you the reference ranges. But how do each of these biomarkers change during aging? And what's their association with all-cause mortality risk? And then, what's the sum of the literature for each of these biomarkers? What's this global story over many papers, not just picking one or two? So I've collected all of that data using 48 published references and collating it into more than 2 hours of video content. So if you're interested for what's optimal for these 33 biomarkers, including ApoA1, check it out on Patreon. All right, so now back to our story with triglycerides, which here too, I've coded that as red. Even though 65 isn't terribly high, I mean, it's lower than the reference range of 150. What's optimal for triglycerides, at least in terms of heart disease mortality risk, or lowest risk, is associated with less than 45 milligrams per deciliter. So that's my target, and 65 is a bit higher than that, so I've coded it as red. Next up is HDL at 65 is just at the border for what's optimal for HDL, 65 to 120, and that's based on a study of 4.5 million people, and I covered that story in depth on the Patreon tier, what's optimal for biomarkers. I know that there's some debate and some confusion that some people think that lower is worse for LDL in terms of all-cause mortality risk, and that story basically comes down to reverse causation, and I go into full detail in that story in the Patreon tier, again, the what's optimal for biomarkers. Even with that in mind, though, in that study of 4.5 million people that accounted for 11 comorbidities that can impact the association for LDL with heart disease mortality risk, there was a small but significant increase for LDL values less than 65. So I don't want to go below that, and I'm right at that borderline. So I've got my eye on LDL. And again, this isn't taking statins. This is, drug-free, medication-free. I'm not taking anything to keep my LDL relatively low. So I'm not trying to go below 65, though, is the point. So I've got my eye on that, and I'll try to stay a bit higher if I can. Now, note that VLDL, which if we take triglycerides and divide that by 5, we can get a pretty close estimation of VLDL, very low density lipoprotein, and LDL contain ApoB. And that's potentially important because, as shown here, we can see VLDL has ApoB 100, which is short for ApoB, and also LDL has ApoB 100, again, ApoB. So that's potentially important because ApoB may be a better marker of heart disease mortality risk relative to non-HDL cholesterol. And in terms of non-HDL cholesterol, as shown there, in my case, it's 79, or at least for this test, 79 milligrams per deciliter. When taking the sum of triglycerides divided by 5, again, that equals or is close to VLDL, and adding that to LDL, we get 78 milligrams per deciliter. So we can see that almost all non-HDL cholesterol in my case is coming from VLDL and LDL. So with that in mind, ApoB may be a better marker relative to non-HDL cholesterol in terms of heart disease mortality risk, and I'll link to that study also. There'll be 4 studies that I'm going to link to in the paper's video's descriptions. So let's check out what my data is for ApoB when considering it may be a better marker of heart disease mortality risk. And that's what we'll see here. So ApoB for this test was 67 milligrams per deciliter. Again, good even just relative to the reference range. But here too, note the papers that they're using to define their reference range. Even though from 2019 and 2020 is more recent than the 2004 paper used for ApoA1, here too there's more recent data and using large epidemiological studies of more than 100,000 people in both studies. So from those 2 studies, which are again on the Patreon tier, lowest cardiovascular and all-cause mortality risk is less than 70 milligrams per deciliter for ApoB. So with that in mind, it's good news. Now, you could say these are very strict optimal ranges. Why are you being so strict? Just follow the reference range. Remember, my goal is to live longer than anyone that's ever lived. And to do that, I'm going to have to science out of aging. And with that in mind, I'm trying to use the best available studies, the best available science from the largest studies, and if I have to be as strict as possible with these reference ranges to maximally minimize my risk, that's the bet I'm going to take. Now, we can also dig deeper and look at the ApoB to ApoA1 ratio, which for this test was 0.49. Again, good based on the reference range, less than 0.77. Now, if we take just what's optimal for ApoB and ApoA1 and divide that, lowest cardiovascular and all-cause mortality may be less than 0.47. So here I'm close, but just a bit outside of it. Nonetheless, that's my target, less than 0.47 for this ratio. And when considering that my ApoB is relatively low, that's an increasing ApoA1 story just by a bit to get that lower than 0.47. All right, moving along to markers of metabolic health, including glucose. So glucose for this test was 90. So at a first assessment, what's optimal for glucose in terms of all-cause mortality risk is in the 80 to 94 milligram per deciliter range. So I'm within range, so technically I'm good. But glucose increases during aging. So how do I compare? Maybe it was 82, 84, 86, and glucose is going in the wrong direction. Well, actually, for my 59 test average since 2015, average glucose since 2015 is almost identical to this test, 90. So this is good news for glucose for this test. But this is only part of the story because a better marker, or at least a better marker of longer term blood glucose levels or insulin sensitivity, is HbA1c. So what's my data for HbA1c? And that's what we'll see here on page 3 of the report. For this test, it was 5.4%. So again, based on all-cause mortality risk, 5 to 6%, and that's in a meta-analysis, 5 to 6% for HbA1c is optimal. In terms of what's found or what's more likely to be found in youth, average values around 5.3 to 5.4% are found in people younger than 30 years. So if I just use those two metrics, technically I'm good and I can just forget about it. But in October of 2023, my HbA1c was 5.1%. HbA1c increases during aging, and whether this is an age-related change or just test-to-test variability, I'm not sure, but the goal is to have it towards the lower end of my range, which would fit within the how HbA1c changes during aging and the meta-analysis data of 5 to 6%. With that in mind, this isn't just a one-test phenomenon of 5.4% for this test. For all 4 tests in 2025, my average HbA1c is 5.38, so essentially 5.4%. So I've got some work to do to bring it back down to 5.1%. All right, let's move on to liver health and function biomarkers. First, starting off with albumin, you can see I've coded that as green. Albumin is relatively high, that's good news. Declines during aging, and lower levels are associated with an increased all-cause mortality risk. Alkaline phosphatase, values less than 48, are associated with an increased all-cause mortality risk. Again, all these data are on Patreon, in the Patreon videos. So that my data for this test at 41 is good news. But then AST and ALT have some room for improvement. Although 26 doesn't seem terribly high, what's optimal for AST and ALT, and this too is based on a very large epidemiological study of more than 10 million people, 27 and 29 respectively for AST and ALT is associated with a significantly increased risk of all-cause mortality. So 26 is pretty close to both 27 and 29. So I've got, or my target then is to reduce it to the high teens, low 20s, which is associated with lowest all-cause mortality risk. All right, next up, I'm measuring total levels of IgG or immunoglobulin G. And that may seem like an obscure biomarker, but I recently had a video on the channel, or I interviewed the scientist on the channel, a scientist on the channel whose group showed that genetic reduction of IgG extended lifespan, and interventions that extend lifespan, including calorie restriction, exercise training, and parabiosis, have lower levels of IgG. So whether that's cause or effect in that case, nonetheless, lowering IgG, at least genetically, extended lifespan in mice. So can that also be the case in people? I don't know, but I'm willing to I'm willing to do the experiment to see what my IgG levels are, to potentially avoid any age-related increase and keep them relatively low to gain any potential lifespan extending effect. So now, with that in mind, I'm not sure if 1,000 in my case is optimal or 700 is optimal. So what I'm planning on doing is testing IgG for every test going forward, and then doing a biomarker versus biomarker analysis. So IgG versus not just the standard clinical chemistry biomarkers, everything you see on the lab report here, but I've also got metabolomic data that I can look at to try to get more insight. All right, next up are thyroid hormone biomarkers, including free T4 and free T3. In terms of what's optimal, I'm very close. So less than 0.8 is what's optimal based on all-cause mortality risk for free T4, and greater than 3.2 is associated with lowest risk of death for all causes for free T3. So I'm right at that border. FT4 is a bit too high. And also what's important here is the ratio, because the conversion of FT4 to FT3 declines during aging. So with that in mind, my data until mostly recently was 0.2 or less. You can see that my ratio for this test is higher at 0.36, so this is good news. Now, I wish I could say that something in my diet or targeted supplementation did the trick, but this is a medication story. So I was able to convince my doctor that I wanted to lower my levothyroxine, my T4 dose, which they did, and then they added in T3. So that's the only reason my thyroid hormone levels are now where they are and have improved. All right, next up is cystatin C. Now, the primary reason that I've included cystatin C is that it's one of the 7 protein biomarkers that the epigenetic clock, GrimAge, which is the best epigenetic clock amongst about 10 epigenetic clocks for evaluating all-cause mortality risk, cystatin C was one of the 7 biomarkers used in that prediction. In other words, Grim age is an epigenetic prediction of 7 actual protein biomarkers. One of those biomarkers is cystatin C. As we'll see later, beta-2 microglobulin, or B2M, is another one of those 7, and I'm tracking those for every test. I'd rather have the actual biomarkers than the epigenetic prediction of those biomarkers. All right, so what's optimal for cystatin C? Less than 0.7 is optimal, and with that in mind, in January of 2024, my 0.72 was pretty good news. That should actually be coded red. So then I forgot about it, right? I thought, oh, I'm good. This isn't something that's going to change too quickly. I don't have to worry about it. So for 7 tests in a row in 2024, I didn't measure it, forgot about it. But then I thought, all right, let's take a look in 2025. And this 0.84 for this test may not be an anomaly, because for the first 4 tests in 2025, cystatin C's average is 0.81, which obviously is higher than 0.72. So I've got some work to do to reduce cystatin C consistently to 0.7 or less. And as a quick side note, when you hear people say that they've got quote unquote perfect biomarkers, this is impossible. All biomarkers, even with all of the standardization that I do, so no exercise or no major exercise 3 to 4 days before the test, standardizing hydration status on the morning of the test, standardizing the fasting window, how many hours that I'm fasting before each test, and then even standardizing the day before diet, so that makes a minimal impact relative to all the dietary changes that I made for, say, the 50-day period in between tests. There's going to be some test-to-test variability, and it's impossible to eat exactly the same diet, exactly the same foods every single day in exactly the same amounts, unless you're a mouse in a cage. So there's going to be some test-to-test variability. So with that in mind, for anyone who says that they have perfect biomarkers, I want to see all of the data. Please show all of your data. And this isn't targeted at one person. This is just a broader comment to the full longevity community. To really have perfect biomarkers, we need a lot of data, and then we need to look at year-to-year change. All right, so now moving on, cystatin C isn't just a biomarker that's used for grim age. It's commonly used to evaluate kidney function, in particular eGFR, the estimated glomerular filtration rate, hard to say. Now, my eGFR using cystatin C is 101. Now, that's potentially important because cystatin C may be a better biomarker relative to creatinine-based estimation, or eGFR, of kidney function. And that's because creatinine levels are proportional to muscle mass, where cystatin C is less sensitive to changes in muscle mass. Muscle mass declines during aging, hence creatinine levels will decline during aging if muscle mass has declined. But on the other hand, kidney function can decline during aging, thereby leading to more creatinine in blood. So someone can have the same creatinine levels at an older age that they did at youth, but muscle mass has declined and kidney function has worsened. So with that in mind, cystatin C may be a better measure relative to creatinine-based estimation of kidney function. So how does cystatin C-derived eGFR compare with creatinine, at least in my case? And when looking at eGFR calculated with creatinine, we can see that it's 105, in the same ballpark as cystatin C estimated eGFR. So they're relatively close and pretty much the same. In terms of eGFR, in terms of what may be optimal, eGFR values of 100 are average values found in 30-year-olds. So this is good news. All right, moving on. Total levels of white blood cells were flagged by the lab at 3.6. And here's one where I agree with the lab, and this is indeed low. Now note that I don't specifically focus on tracking total white blood cell counts. Especially in terms of like when I look at correlations with diet or supplements, I'm not looking at correlations with total white blood cell counts. And that's because white blood cells are not a homogeneous group of cells. They include neutrophils, monocytes, and lymphocytes as more than 97% of total white blood cells. So tracking those individual cell types are more important to me, or provide more information to me, especially when considering that neutrophils and monocytes increase during aging and lymphocytes decline during aging. All right, so first, neutrophils at 1642 is on the lower side. In terms of what's optimal, neutrophils increase during aging, and 2,000 to 3,000 is associated with lowest all-cause mortality risk. Values greater than 3,000 and less than 2,000 are associated with an increased risk. So with that in mind, I've coded my neutrophils as red, as that would technically be associated with an increased all-cause mortality risk. Now, I'm not yet sure if less than 2,000 in my case would be potentially bad for health. To address that, I'm going to do biomarker versus biomarker analyses, neutrophils versus all the other biomarkers to get more insight. When considering that they increase during aging, having them relatively lower in my case. Now, that's within the context of low hsCRP and in previous tests, very low levels of IL-6 and TNF-alpha, pro-inflammatory cytokines, may be good news. But I can see the situation and maybe in an older adult who may have low levels of neutrophils, maybe because they can't produce them, within the context of elevated inflammation. And that would be potentially bad news. It would suggest that they don't have enough neutrophils to clear any microbial invaders, that are systemically around, right? So I can see that situation being a problem at advanced older ages. That currently isn't the case for me. So it's possible that 1642 may be good news in my data, but still playing it by the book, I've coded it as red. In contrast, I think that the lymphocytes being 1566 is bad news. And that's because lymphocytes decline during aging, and values around 1900 to 2100 are associated with lowest risk of death for all causes. As lymphocytes decline below 1900, that's associated with a big spike in terms of all-cause mortality risk. And again, all of the plots are in those more than 2 hours of video content on Patreon, so if you're interested in that, check it out. Now, good news though, for this test, lymphocytes were higher than they've been for the past 4 tests. And you can see that they were even lower for the past 3 tests before that. And the way I'm doing that is I track diet, and I'll go into the diet story more in the next video in this series. The diet that was underlying, this 17-year younger biological age for the May 27th test. But I track correlations with diet and supplements, and then based on what the correlations show, I tweak things in the diet or supplements to try to move biomarkers towards the right direction. In terms of the right direction, how do these biomarkers change during aging and all-cause mortality risk? So whether this is something that I did or just test variability, I'm not sure, but I did intentionally follow a few correlations to try to increase my lymphocytes, and I'll have more on that in the next video. All right, I'm also tracking Candida IgG, and this goes into the immune story. So for 11 tests in a row, Candida IgG has been higher than the reference range. And I can't say why that is, but it is what it is. If we go back to 2017, I have one test, and I wasn't intentionally measuring it. I did a food sensitivity panel that happened to measure blood levels of Candida IgG, and there too it was high. So this may be a problem that goes back at least more than 8 years. So with that in mind, I was prescribed, or I went to the doctor and asked for a prescribed antifungal, as nothing in the diet has worked. I've been following the correlations. Nothing has worked to bring Candida IgG lower than the reference range. And just as a quick side note, you could say, well, just because it's higher than the reference range doesn't mean anything. You don't have an active infection because IgM isn't relatively high. But that you've got relatively high Candida IgG, your immune system is keeping it in check. And that's true. But it suggests that my immune system is doing a bad job of keeping it in check, leading to relatively higher levels of IgG than it would need if it was able to do a good job of keeping it in check. And when you put it in the broader perspective that higher levels of total IgG, so Candida IgG feeds into total IgG, may be bad for lifespan, I find it important, or I think it's important, to try to bring or help my immune system bring systemic Candida levels in check, thereby reducing Candida IgG. So I asked my doctor for a prescription of fluconazole, which is a prescribed antifungal. I took the lowest dose, 200 milligrams per day for 12 days after this test. And I did that for a June 11 test. And unfortunately, it didn't reduce Candida IgG below the reference range, so still high at that dose. Now, I still do have some fluconazole. I'm planning on, if the next test on July 22nd, so coming up really soon, if it's not lower, and I've been following some correlations to try to impact Candida IgG without any prescribed antifungals, I'm planning on testing again with fluconazole, only this time with 400 milligrams per day. And because I only have a 1 month supply, I can only do that for about a week. So that'll be probably sometime for an August test, assuming that I haven't figured out the Candida IgG story for the next test later in July. Now, another weak spot is, or at least for this test, was DHEA sulfate. So DHEA sulfate declines during aging with values around 300, or average values of around 300, more likely to be found in 20-year-olds relative to people that are chronologically older. Now, 110 is my second worst or second lowest DHEA sulfate value over 22 tests since 2022. And this is below my 22 test average over that time too. So this definitely moved in the wrong direction. Now, part of this story, as a side note, because I'm still doing the analysis on my own before I see if there's a real story here, but I did a biomarker versus biomarker analysis, and when considering that cholesterol is used to make DHEA, and correspondingly sulfation leads to DHEA sulfate, LDL is positively correlated with DHEA sulfate in my data. But when considering that higher levels of LDL will increase or potentially increase ApoB, I'm not sure that I want to increase LDL to increase DHEA sulfate. So I'm currently looking at correlations between the ratio of DHEA sulfate to LDL. In other words, the conversion. Can I impact the conversion of LDL to DHEA sulfate without raising LDL? So that's one strategy. I've got some other ideas that I won't go into this video, but I've got a few thoughts about how I may be able to reverse my DHEA sulfate. And again, that's without taking exogenous DHEA. I can definitely do that, but this is almost like waving the white flag in my case. It's basically like me saying, I can't do it endogenously. I have to do it exogenously. I can't rejuvenate myself systemically, just doing it quote unquote naturally. Even though I'm not opposed to doing it exogenously, I want to give some time and have enough tests to really try to learn the recipe for improving DHEA sulfate and other biomarkers before I go to the exogenous route. Now you could say, all right, what about your thyroid hormones? Well, that's a story that goes back to my 20s. I was diagnosed with hypothyroidism in my mid-20s, and I had thyroid gland atrophy. So I've been taking thyroid hormone meds for more than half my life. I'm not sure I've got adrenal gland dysfunction, thereby leading to DHEA sulfate relatively low levels, at least not yet. But I'd like to collect more data before I would jump on the just take DHEA and that should increase DHEA sulfate bandwagon or train. I also mentioned that I'm measuring B2M or beta-2 microglobulin because it's a part of GrimAge. And again, I'd rather measure the actual biomarkers than the epigenetic prediction, even though GrimAge is an epigenetic clock for its epigenetic prediction that's associated with all-cause mortality risk is the best amongst 10 clocks that were studied. And I covered that in an earlier video. If you missed it, it'll be in the right corner. In terms of what's optimal for B2M, lower is better. And 1.55 isn't terribly high, but I prefer to have values closer to 1 than where they are right now. I only have 2 tests, so I can't say what the recipe is for moving it lower. And there isn't anything published that, how do you keep B2M low? So stay tuned for that story in a future video because I've got to collect a lot more data in order to know what may impact it. All right, next up, onto red blood cell related measures, including the red blood cell distribution width, which for those who don't know is the major predictor of biological age using Dr. Morgan Levine's biological age clock, which I mentioned in the beginning, PhenoAge. So 12.2 is technically good news if we look at what's optimal for RDW, and this is based on a study of 3.4 million people. We can see that lowest all-cause mortality risk was associated with 11.4 to 12.6. So with that in mind, 12.2 is good news. I'm within that tighter optimal range relative to the reference range. But if we look at the most recent data, for the past 5 tests, the data is moving in the wrong direction and RDW increases during aging. So for the past 5 tests, you can see 11.7, 11.8, 11.8, 12, 12.2. It's going in the wrong direction. So this isn't just about, am I within the optimal range? It's, am I following the age-related trend or resisting it? Following the trend or resisting the trend. In my case, at least for the last 5 tests for RDW, although it's in the optimal range, it's moving in the wrong direction. So I've got to try to push it lower if I can. And again, to do that, I follow what the correlations show with diet and other variables. I also track 2 other red blood cell related measures, including the MCV, the average red blood cell volume. So the average volume of red blood cells increases during aging, so hence the MCV increases during aging. So 92.3 isn't terribly high, especially when considering that my average for 2025 is currently 92 over 4 tests, which is better than the 8 test average in 2024 of 92.7. But both of these data are worse than my 57 test average since 2015, which is 90.7. So the goal is to get it closer to 90.7, even a bit lower, as that's associated with lowest risk of death for all causes, if I can. So we can see that my data is starting to track in the wrong direction. So I've got to try to follow correlations the best that I can to try to move that away from how it changes during aging and towards the increased all-cause mortality risk. I'm also tracking hemoglobin, and here too I've coded this as red, even though lowest all-cause mortality risk for men is in the 14 to 15.9 range. Now, the range is a bit different for women. I covered that in the Patreon video, but that's a story for another day. So 14.6 is within that range, and technically not bad news, right? Well, my average hemoglobin since 2015 is 15, and that's over 15 tests. So the goal is to get it back there. Now, adding more context, over 8 tests in 2024, average hemoglobin was 14.8, so a bit below that 57 test average. And after the first 4 tests, it's 14.7. So you could say, I'm being nitpicky, this isn't a big deal, these are tenths of a gram per deciliter, but let's play this out. If my 8 test average for hemoglobin declines by 0.1 gram per deciliter per year, after 10 years, that's 1 gram per deciliter lower. Now it's not 14.7, maybe it's 13.7. Now that's associated with an increased all-cause mortality risk. Even if you slow the rate of that down, where it's 0.05 grams per deciliter decline per year, after 20 years, now I'm still lower than that optimal range of 14 to 15.9. So my goal is to get it back to 15 if I can, and follow the correlations as best I can to try to resist age-related change. 2 more biomarkers. hsCRP, 0.2 milligrams per liter. This is the lab's detection limit. They can't tell me, unfortunately, Quest can't tell me the actual value below 0.2, but it's not higher 0.2 as that's their limit. And this is good news. I've coded it as green because it's now 25 consecutive tests where hsCRP is less than or equal to the lab's detection limit, which was 0.3 milligrams per liter. For the past 9 tests, for whatever reason, Quest has improved the sensitivity of their assay, or at least reporting to a lower limit. And for 9 consecutive tests, hsCRP is less than 0.2 milligrams per liter. So the hsCRP data is good news, and this is going back for more than 3 years. On the other hand, another weak spot, and again, see, I have weak spots. Pheno age may be good news, my biological age may be good or great news, but I do have some weak spots, and I'm trying to cover all the weak spots. There is no such thing as everybody has perfect biomarkers. And if I'm wrong, and if someone has perfect biomarkers at relatively older ages, please show your data and let's share how you're doing it, because I think the community would benefit. So homocysteine at 10.7, here too isn't terribly high, but I've had values that were half that about 20 years ago. So and here at this point in the video, I can already hear a lot of you saying TMG, take TMG. I've done that experiment. 4 grams of TMG didn't make a dent in the past, but somebody on the channel commented maybe you're zinc deficient, and that may be part of the reason why. So betaine methyltransferase requires zinc for maximal activity. My diet, although it's not low in zinc, it's above the RDA, consistently above the RDA for every test. Maybe that's not high enough. Maybe the phytates that are in some of the foods that I eat, including nuts and seeds and whole grains, maybe that's limiting zinc absorption. And then for those who are not on a high fiber diet like me, maybe they'll say, oh, go keto, go carnivore. One step at a time. I'm going to test the hypothesis that maybe suboptimal zinc levels are associated with this homocysteine story, or at least homocysteine moving in the wrong direction. What the mechanism is yet, I don't yet know. Whether it's a phytate story, I don't yet know. But I've added supplemental zinc, a relatively low dose, into the diet to test that hypothesis, and I've added some sources of dietary betaine that I took out for a few tests, including beets and amaranth, which I added. That's actually a new addition, which contain trimethylglycine or betaine, in conjunction with that zinc supplementation to see if that can bring homocysteine down for the July 22nd test. Now, there's another part of the homocysteine story that's important to mention. Homocysteine on its own accelerates cell senescence, at least for endothelial cells and for neurons. Now, that's important to say because whenever I bring up homocysteine as a metabolite, there's always people who say, well, lowering homocysteine doesn't improve cardiovascular-related outcomes in randomized controlled trials. Now, that may be true. Maybe reducing homocysteine doesn't impact it in people who have pre-existing CVD. On one hand, I'm looking at it as a preventative measure. I'm trying to keep it relatively low so I don't end up with CVD, and then I'm not trying to reduce homocysteine and see if that improves CVD-related outcomes. On the other hand, too, when considering that homocysteine on its own can lead to cell senescence, at least in vitro, of endothelial cells and neurons, I'm trying to keep it as low as possible, again, as close to 5 as possible. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I include blood test consults for those who are interested in optimizing their own blood test data. And on Patreon, I post at least twice a day in those other 4 Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including altalabtest.com, where I get the majority of my blood tests, the clearly filtered water filter, which I'm using every day, at-home metabolomics, and test results for test number 18 just came in, so I'm currently analyzing that. Oral microbiome composition, I'm still battling the Serratia story, so stay tuned for some update videos probably coming later in the year. NAD testing with Ginfinity, epigenetic testing with True Diagnostic, at-home blood testing with Cyfox Health, which includes the GrimAge, the DNA methylation test GrimAge. So if you want the best epigenetic clock amongst the 10 epigenetic clocks, that's the one to get. Or maybe you want to measure the protein biomarkers, including cystatin C and B2M, as I'm doing. Green tea, drinking it every day. Diet tracking with Chronometer, doing that every day too. Or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, including the Figuring Stuff Out is My Drug, which is probably going to be my most favorite shirt of all time because it's true. It's basically my motto. This is the most important thing in my life. Figuring stuff out is literally a drug to me. Or we've got other merch, including the one I've got on here, ConquerAging or Die Trying, the channel's theme. Links to that are in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.